address IP packet at the data link interface. It's data link. So the data link frame with an encapsulated IP packet will arrive to the ingoing interface of the router or the ingress interface of the router. When the packet arrives from the incoming interface, what does the router do? Basically, the router examines the destination IP address. First of all, he will check, he will remove this. He will check the destination IP address in the packet. When the router knows this destination IP address, okay, he should look the routing table if he has a longest match. Okay, so the router finds the longest match prefix in the routing table. We assume that. Then, if it finds, the router encapsulates this IP address, IP packet, in a data link frame. Then it encapsulates, then forwards this packet to the outgoing interface of the router or the egress interface. The decision could be a device, the destination, sorry, could be a device connected to the network. It means that directly connected network or next hop router, as here. Here, for example, next hop router, and it could be this way, immediately connected to this LAN without passing this router. Okay. So, however, if there is no match, the router will drop this this packet. Okay. So the router receives the encapsulated IP. The router examines the destination IP. If it finds the IP, it will consult the routing table. If it finds destination, either it forwards this packet through the egress or outgoing interface to the next hop router or to the directly connected network. If there's no match, it will drop this packet. Okay. How does the router now took the decision? So, packet forwarding decision process. How a router, after receiving this packet from the ingress interface, take a decision. After a router has determined the best path, it could do the following. So the router receives a packet, checks the destination IP with the packet, consults the routing table, okay? And now, how does a router really take the decision, I want to use this path 3 and not 1, 2, or 4? Why? So he will do the following. Forward a packet to a device on a directly connected network. As we explained earlier, it means that if the router or if the route, the IP address with the longest match with the destination IP address, and this IP address is really directly connected to the network, then now the router will immediately directly forward this packet to the destination, and what we call Ethernet LAN or LAN. So the directly connected network, it means that we don't have another router after when the packet exit from the router interface, it goes immediately to LAN. It doesn't go to another router. This is directly connected network. Okay. So now to encapsulate the packet in Ethernet frame, the router needs to determine the destination MAC address because the destination is a network and it's not a router. I mean switch. So if the router is connected to a switch, what does it mean? It means that the switch will use MAC data link at level 2, layer 2 address. So the router should use some RARP, ARP information in order to know which MAC address should include in this encapsulated message to forward to the MAC address within this LAN network. Okay, so the router needs to determine the destination MAC address associated with the IP address of the packet. That process varies based on whether the packet is an IP version 4 or IP version 6. If it's IP version 4, it will use the ARP, RARP message or ARP message, address resolution protocol, in order to find the corresponding MAC address for this IP packet. We don't use ARP and RARP address resolution for IP version 6 packets, okay? Now we will talk about also another type of connected interfaces to the router. First thing, if it's directly connected to a LAN, or what we call directly connected network. And the second thing is if we have the next hop is a router, it's not a LAN. How the router should forward the packet. If a route entry indicates that the destination IP address is a remote network, it means remote network, this remote network, and this router, for sure there is another router between this router and this remote interface, as in our example here. So imagine that this is the router and wants to forward a message to here. So this interface or this router now, it's not directly connected network to this router. No, this is forward second router, and this router will find. So this LAN for this, it's not directly connected, but this LAN for this router is directly connected. Okay? This LAN for this router is directly connected, but this LAN for this is not directly connected. So we are in this case, okay? So if the route entry indicates that the destination IP is a remote, meaning a device on network that's not directly connected. That's it, true? Now, the packet must be forwarded to the next hop router. Okay, and next hop address is indicated in the route entry for sure, in order to so if R1 will route the information to the LAN here, it first should forward the message to R2, and R2 will forward the message to the LAN. Okay, so it will add next hop. If forwarding router and the next hop router are on an Ethernet network, a similar process of ARP and ICMP discovery will occur for determining the destination MAC of the packet as described previously, for sure. If it's directly connected, I mean from router to the LAN immediately, there is no in the middle router, we will use the ARP and ICMP to learn about the MAC address to forward this packet to the LAN. Okay, so the difference is that the router will search for the IP address of the next router in its ARP table or neighbor cache instead of the destination IP address of the packet. So there is two things the router should do now for packet forwarding decision problem. If it's directly connected to a LAN, it should look for the IP address of the destination and find its MAC address. However, if the next directly connected to this router is another router, it will consult or find the IP address of this router. It doesn't search for the MAC address. Okay, so this is the point. Now, okay, packet forwarding decision process continued. So if there is no match at all, neither it doesn't have zero match and doesn't have default route, so the router will drop this packet. Okay, if it doesn't find match between the destination IP packet address and between the route entries within the routing table, and there is no defined default route, the packet will be dropped in this situation. End-to-end packet forwarding. The primary responsibility of packet forwarding function, for sure, is to encapsulate packets in the appropriate data link frame type of outgoing interface. For example, the router uses different interfaces, and the router could define at each interface a specific kind of protocol. So based on each interface type, the encapsulation should be different. Okay, so if the router has a serial data link, the encapsulation should be a point-to-point protocol encapsulation frame type. And if it could use HDLC packet encapsulation if we have another interface type or interface that's linked to a protocol, a link that use some protocol, network that use some protocol. Okay, then a packet forwarding mechanism. So we have talked about the router will use packet forwarding process decisions. So based on what the router should do that. So routers support, in order, the primary responsibility of